On the 6th of January 2021 was the insurrection of the Capitol building in America. 5 died, 150 were injured, and a political system was found to be in disarray. This was as a direct result of disinformation about voter fraud that was propelled on social media. So what is it about disinformation that makes these messages so compelling and spreads this fear and suspicion so wide? Let's take a look at this example. It demonstrates 3 linguistic tactics that are used in order to make disinformation more effective. The first is an ad hominem attack. This is where you attack someone's character rather than presenting the argument itself. So here, those who choose to get vaccinated are labeled fools. The second is an appeal to emotion. These highlighted words here have been specifically chosen to evoke feelings of fear. The third is a fallacy of logic. This is where an illogical argument is presented as if it's coherent, but without any evidence. For example, the vaccine being a fast track to death. So my fellowship project was looking at whether we could detect these disinformation tactics on social media networks. My first job was to define some data sets. So for training, I found an open source data set, which was created from scraped examples of each tactic from textbooks and quiz websites. So it's labeled. For every sentence, I know which tactic it contains, if any. And then to deploy my models, I curated my own vaccine disinformation tweet data set, which was scraped from the platform X. So this is unlabeled. So the idea is, using this textbook data set, can we essentially create models to label the tactics in the Twitter data set with a certain degree of confidence? So the first model I used as a baseline was an old school NLP model called the bag of words. Now here I'm showing model performance, 1 being perfect, 0 being always wrong. And for each tactic, we can see that this bag of words model does not very good. We're always getting performance lower than 0.5. So we can definitely do better than this. We've done the old school model. What about the new kid on the block, ChatGPT? What if we asked ChatGPT to classify each tactic in each sentence? What model performance are we looking at then? We can see that we do a lot better now. So the performance clearly increases. To the ad hominem tactic, we're getting accuracy of around 0.8. So we see this on paper for performance increase, but should we actually trust this? Well, let's deploy it on our vaccine disinformation Twitter data set and have a look. So if I ask ChatGPT, what is the probability that this statement contains an ad hominem attack? What does it tell me? First, it gives me a score of 0.9. It's fairly certain that there is an ad hominem attack in this sentence. Now, if I put the same sentence in again and run it again, what does it say? Now I'm getting a score of 0. And if I do it again, I get a score of 0.6. So these classifications from GPT and this labeling from GPT, it's not only giving me different answers, but more worryingly, it gives very realistic sounding justifications for each different answer. So it's not only inconsistent, but it's also unexplainable. Ultimately, GPT is designed to generate new and different text. So can we actually use that fact to our advantage? Well, I mentioned at the beginning that the dataset was made up of textbook sentences. Now, this one here contains the fallacy of logic. So with some prompt engineering, we can actually use GPT to create a version which retains both the content and the tactic, but we can make it sound something that's more like something that's more similar to a tweet. We can even go one step further. We can retain the content and make it sound like a tweet, but without the tactic. So now we have a bigger and better data set of tweets, not just textbook sentences. And we can use this data set with our next model, which is a deep learning model that we fine-tune and train with our enhanced GPT dataset. So now we're looking at a much more consistent model performance across each tactic, and also one that's very high. And remember, this performance is on this more complicated GPT enhanced dataset where the language is a lot more varied. So the task is actually much harder and it's still doing really well. Now, what happens when we deploy this on our real world data? We get predictions which are very reproducible. So if I put the same sentence into the model, the trained model at any time, I will always get the same score out. And if we go one step further and we use some explainable AI methods, we can also generate explainable scores. So the color here corresponds to how much each word contributes to the positive score. So red contributes to the positive score, blue is negative. So to conclude, we have found that GPT-4 is useful as a means to generate new data specifically. The deep learning model offers the most consistent performance and also the most tunable model, and also demonstrated the importance to train on relevant data when considering the deployment task at hand. Thank you for listening.